Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 4 variant 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 7 says, a varying current I passes through a resistor of resistance capital R in the circuit as shown in figure 7.1. The current has magnitude 2I0 when it is in the positive direction and I0 when it is in the negative direction. The period of variation of current is capital T. Determine expression in terms of I0 and R for the power P dissipated in the resistor for the times when the current is in the negative direction and when current is in the positive direction. So simply we need to understand the power, because this is constant, current is constant, so power simply will be equal to I square times R, the same as we do for DC circuit. Now in this case value of I is given to us, that is I naught, so simply we will replace I with I naught, so this is I naught square times R. So this is how you can calculate power when current is in the negative direction. And for the positive direction, we have to repeat the same method. For DC current, we use I squared times R. But in this case, value of current is 2I0, so simply we have to replace I with 2I0 square times R. So if we solve this one, we will get 4I0 square times R. So this is how simply you can calculate. Part B says on figure 7.3 sketch the variation of P with time t between t is equal to 0 and t is equal to 2.0. Capital T means t is equal to 2 times of time periods. Label the power axis with an appropriate scale. So first of all we need to understand, for this part we have discussed that power is equal to I naught square times R, and for this part power is equal to 4 times I naught square times R. So if we take this here 2 times I naught square, so this one has to be equal to 4 times I naught square times R. So this is how we can choose our scale. Now for this part, halfway, because this power is I naught square times R, so we can take 5 small square from here. So this is 1 2 3 4 5, and now simply we can draw a line. So simply we need to draw the line. From here we can draw this line here, and after the power is 4 I naught square, so we can draw the line here. And for this part again power is I naught square, so this is, you can draw this horizontal line here, and then we can draw the horizontal line here. So if you draw these 4 horizontal lines, you will get 3 marks. You can also connect them by dotted lines. Let me show you the better shape of this. You can also draw this one in a better way, so this looks a bit better. So we can also draw like this. Let's try to answer this extra question for your better understanding of alternating current. If you can handle this question, it means you have good understanding of alternating current. And questions about alternating current you will be able to answer. Pause the video, do question by yourself, and then come and compare your answer with my answer. For this question, it is given to us the variation with time of an alternating current in a resistor of 120 ohms is shown in the figure. What is the value of its RMS current? RMS current. And for part B, we need to calculate what is the mean power dissipated by the resistor. Mean power. So first of all, we need to calculate RMS value, IRMS. In order to calculate IRMS, first of all we will calculate mean square current. Mean square current. How we can calculate mean square current? So we will take this value here, so we will take the square of this value, so we have 4 here, so this is 4 square, plus we will take this value. square of this value. So we will simply take square of this. We need to calculate mean square. So we have to divide this one by 2. So we can calculate mean square current. And if we solve this one, we will get 12.5 amps square. So how we can calculate IRMS? IRMS means that root mean square. So simply we have to take the root of this one. So we can write on here, we have mean square. If you take the root of this one, so this is root mean square, mean this is IRMS. Value of mean square we have, that is 12.5 amps square. Now simply we have to take the root of this. So if we take root of this, we will get about 3.54 amps. So this is value of IRMS. So this is value of IRMS. Part A we have answer. Now for the second part, you need to understand power, the mean power. Mean power has to be equal to I square times R. And now we need to understand when we compare DC with AC, or we compare AC with DC. So let me write on you very important concept, DC, and here we have AC. So if we compare these two, what value of AC we have to use? For example, here we have AC. If we go this way, we have to use RMS value. So this is the main thing. What we have to use? RMS value. So this is formula for DC. So if we want to use this one for AC, we have to use IRMS. So it has to be IRMS square, because this is for DC, this is for AC, times R. Now simply we can plug in values. We have 3.54 square of this value times we have 120, and if we solve, we will get about 1500 watts. So this is the main concept you need to understand, how AC and DC, they are comparable with each other. If we have AC current, how we can find the equivalent DC current for that? So you have to use RMS value. It simply means that all DC formulae, for example, if I need to calculate power, for example, power for DC is I square times R. How about power for AC? This is for DC. How about for AC? AC power will be equal to IRMS square times R. And if we write down for DC, for example, the power we have, this is V square times R. So how about for AC? Power will be equal to VRMS square by R, and so on. So how DC and AC, they are connected with each other? By RMS value. So this is importance of RMS value. I hope this makes sense, and look at this question again. If you have any questions, please leave your questions in comments. And if these videos are helping you, please like and subscribe, and also share with your friends. And if you're looking for more resources, you can also join Patreon. Part C says use the answer in B to determine an expression in terms of I naught and capital R for the mean power in the resistor. So how do we calculate mean of something? In this case, we need to calculate mean power. So mean power simply will be equal to P1 plus P2 divided by 2. And value of P1 means when current was in the negative direction, we have already determined that was equal to I naught square times R. And when current is in the positive direction, we have calculated 4 times I naught square times R. And this is divided by 2. So simply we will get, in this case, 5 times I naught square divided by 2. So this is how you need to calculate mean power. Simply how to calculate mean. So this is our final answer. If you have got this answer, you will get 1 mark. Second part says calculate the root mean square current IRMS in the resistor. We have already discussed that mean power for AC, this is equal to IRMS square times r. And value of mean power we have just calculated, so we can write down the value of mean power, that is equal to 5 by 2 times I naught square times r, and this is equal to IRMS square times r. So we can cancel this r with r, so we can rewrite here IRMS square, this will be equal to 5 by 2 I naught square. Now if we take square root on both sides, we will get IRMS, this will be equal to root of 5 by 2 times I naught. So this is value of IRMS. Very nice question. This question is a very nice question about AC, means alternating current. If once this question is not clear to you, watch this video again and try to understand concept. Not just look at answers and try to memorize the answers. What you need to do, you have to look at this question again and make it clear that you have proper understanding of this question. If you have proper understanding of this question, a lot of questions about AC you can answer. If still not clear and you need help, you can leave your questions in comments. Question 8 part A says, show that the momentum P of a photon of electromagnetic radiation with wavelength lambda is given by P is equal to h over lambda. H is the Planck's constant. So how we can derive this formula? First of all, we need to understand energy of a photon. Energy of photon, this can be written as product of momentum and C. And energy of photon, we can also write down, this is equal to hc over lambda. So we can say this is equation 1 and this is the second equation. By comparing 1 and 2, we can write down Pc, this will be equal to hc over lambda. So C we can cancel from here, so it means P is equal to h divided by lambda. So this is how you can answer. So here we are comparing, you can simply say by comparing 1 and 2, by comparing 1 and 2. So by comparing 1 and 2, so this is the answer. Second part says, use the expression in A1 to show that a photon in free space that has a momentum of 9.5 times 10 to minus 28 Newton second is a photon of red light. In the last part, we have written that P is equal to h over lambda. Now we need to calculate value of lambda wavelength, so simply we can say h divided by P. And value of Planck's constant is 6.63 times 10 to minus 34 joules second. And this value you can find in the data given on the second page. You can find this value. And value of momentum is given to us, that is 9.5 times 10 to minus 28 Newton seconds. If we solve this one, we will get about 700 times 10 to minus 9. So we can say this is equal to 700 nanometers. And now if we compare this one with wavelength of visible light, wavelength of visible light is about 400 to 800 nanometers. So this one is red light. This is very close to this end, so this is the red light. So this is how you need to answer. Part B says, a beam of red light of intensity 160 watts per square meter is incident normally on a plane mirror, as shown in figure 8.1. The momentum of each photon in the beam is 9.5 times 10 to minus 28 Newton second. All of the light is reflected by the mirror in the opposite direction to its original path. The cross-sectional area of the beam is given to us. For part 1, we need to show that the number of photons incident on the mirror per unit time is 1.4 times 10 to 15 per second. I mean, these number of photons in 1 second, they are arriving this plane mirror. So how we can answer this question? For this question, intensity is given to us, so we can say we have intensity, and momentum is given to us, and cross-sectional area is also given. We have value of cross-sectional area. So how we can answer? So the best way to answer this question is we can start with intensity I. Intensity is equal to power divided by cross-sectional area. And power we can write down, this is equal to the total energy over time times A. So intensity can be written in this form, and this is the total energy, and total energy we can write down n times energy of single photon, So let me rewrite this one here. So we can write down total energy of the beam will be equal to number of photons times energy of single photon. So here we can say this is energy of single photon, and this is divided by T times A. And energy of single photon, as we discussed before, energy of single photon, this is equal to Hc divided by lambda. So this is energy of single photon. So we can replace energy of single photon with this. So we can say this is NhC divided by, we have lambda times T times A. As value of lambda we don't have, so we can rewrite this one. We can say momentum, this is equal to H over lambda. So from here we can say lambda will be equal to H over P, because we have value of momentum but we don't have value of wavelength. So we can replace this lambda. So we can rewrite this. So we have N times H times C, and here we have lambda, that is equal to H over P, and here we have time times A. So if we rearrange this one, we can say this is N times H times C times P, and this is divided by H times T times A. So here we have Planck's constant, so simply we can cancel this, and this is equal to intensity. But for this question we need to find out this N over T. So we need to find out N over T. So we can rearrange this. We can write down here I times A. This will be equal to N over T times, we have C times P. So we need N over T. So we can write here N over T. This will be equal to I times A divided by P times C. So value of intensity we have. This is value of intensity. So we can plug in values simply now. We have 160 watts per square meter, and value of A we have, that is 2.5. So we have 2.5 times 10 to minus 6 square meters divided by the momentum of each photon. So we have momentum of each photon, that is 9.5 times 10 to minus 28, and C is a constant, its value is 3.0 times 10 to 8. Now simplify this one and you will get the final answer. If we simplify this one, we will get 1.4 times 10 to 15 photons per second. So this is our final answer, and this is what we need to show, that this is number of photons per second arriving the mirror. Very systematic approach, and this approach you need for many questions about quantum physics. So you need to understand how to use this. So in the exam, if they ask you something, you can start with this one and you can derive for that. For this question, we have derived this one for number of photons per second, and in the exam they can ask you in a different way. Most of the time this is very handy. This is very important one. This one is very important. In many questions they will ask you about this one. For example, they will ask you if intensity remains constant and lambda increases. If lambda increases, so how about the number of photons? So if everything else is constant, so if lambda increase, it means n also increases, and vice versa is also true. So if lambda decrease, for example, it means n has to decrease. And this question is a very common question in many past papers you will see about quantum physics. Second part says use the information in B1 to determine the pressure exerted by the light beam on the mirror. And pressure is equal to force over area, and force in this case is equal to rate of change of momentum. So we can say this is delta P over delta T multiplied by 1 over A, and momentum change in this case we need to understand. So this one is the mirror, so photon of light come, hit this one and go back with the same momentum. So in this case change in momentum is double because we have delta P. So if we say this momentum is P1, this momentum is P2, and we take to the left positive, so we will say P2 minus P1. So we can say P2 minus P1. This momentum is negative because we are taking to the left is positive, so it means momentum change in this case is equal to 2 times P. 2 times P. So this one is P, this is also P. Magnitude is the same, so we can write on here. So this is 2 times P over T times A. T times A. This is the pressure exerted by 1 photon. So this is pressure exerted by 1 photon. And what is the total pressure? So we can write on here now. Total pressure. So total pressure will be equal to pressure of 1 photon. So we have pressure exerted by 1 photon times number of photons. N is the number of photons. So we can little bit rearrange this one. We can say this is equal to 2P divided by A times we have delta N by delta T, number of photons in a given time here. Now simply we need to plug in values. We have 2, and the momentum value, we have momentum of photon, that was 9.5 times 10 to minus 28 divided by cross sectional area that is given to us in the last part, 2.5 times 10 to minus 6, and number of photons per second we have already calculated, that was equal to 1.4 times 10 to 15. Now if we solve this one, we will get 1.1 times 10 to minus 6 pascals. So this is total pressure by the light beam. Total pressure by the light beam. So this is how you can calculate. So this is our final answer. So this is pressure exerted by 1 photon, and this is the total pressure exerted by all the photons. Part C says the beam of red light in B is now replaced with a beam of blue light of the same intensity. Intensity is the same. Suggest and explain whether the pressure exerted on the mirror by the beam of blue light is less than, the same as, or greater than the pressure exerted by the beam of red light. Nice question, and this question is based on part B. In part B we have already discussed that pressure is equal to 2 times P, this is the momentum, 2 times P over cross sectional area times we have discussed this is number of photons per unit time, delta N by delta T. In order to answer this question, so let me write on here, this is representing pressure and this is representing momentum. In this case intensity is the same. I can explain you this one with the help of this. I can simply say momentum increases because momentum is P, this is equal to E divided by C. As energy of each photon increases, it means momentum increases. So it means this one will increase, but number of photons will decrease. So it means pressure remains constant. In a simple language I can explain, but let's try to understand this one in more detail so you can have better idea. So what I have said is that if energy of each photon increase, so it means that momentum of each photon will increase. So if momentum of each photon increase, cross-sectional area is the same, so dN by dt will decrease. So it means momentum will remain same. So this is one way to explain. But maybe this explanation is not very clear. Now let me explain you this one in a better way. Intensity is the same. So intensity we have discussed. Intensity is equal to P over A. We have discussed this point already, and we can say this is equal to the total energy E total over T times A, and total energy we can say this is N times energy of single photon. So this is energy of single photon divided by T times A, and here we have the intensity. And energy of single photon, we can say energy of single photon, that is equal to momentum of the photon times C. So we can rewrite here. So we have N times P times C divided by T times A, and this is equal to intensity. From here we can say momentum, P is the momentum, that will be equal to I times T times A divided by N times C. So this is here momentum. Now we can replace this momentum with this value. You can write down here, this is 2, and we have I times T times A, and this is divided by N times C, and we have here this is N divided by T, and we have value of A here as well, so we can write down this is 1 over A. Now you can see here this N we can cancel with this N, then this T we can cancel with this T, and this A we can cancel with this A. So if intensity is the same, it means pressure is the same. I hope this makes better sense. So we can simply say, as in this case, intensity is the same, and this is just constant number, so it means pressure is also same. So this is how you can answer this question. I hope this makes sense. Now let me show you the answer, how you can write down your answer. In your answer, you can write down these points as I explained you with the help of this equation. So simply we can say photon have greater momentum. As energy of each photon increases, its momentum of each photon increases, but fewer photons per unit time. So this means delta N by delta T, this one decreases. Greater photon momentum but smaller number of photons per unit time, so pressure is the same. So this is how you can answer. I hope now you have better understanding why pressure is same when intensity is same. So next time you can understand, as long as intensity remains same, pressure remains same.